Yeah.
This is the computer resource usage monitor. I'm Tom Mackinson.
I'm Samantha Bailey.
And I'm Paul Ippolito. All right, so for this project, I will be taking care of the front end. I will be designing our user interface, implementing it, doing our final displays and updates of the data, and working with the API calls that affect the UI.
I'll be taking the backend and the main API. So I'll be working with the Java library called Oshi to actually gather usage information for different parts of the computer, passing it on to the front end to display it, and to the back end to store it.
And I will be handling the database. I'll be creating, designing, implementing, and maintaining the database so that any information that is sent from the main program can be stored.
So our objective for this project is to provide users with an easy to operate resource monitor. We're trying to focus mostly on low overhead. We don't want to impact the computer itself while we're capturing information, and we're captured from different devices: the CPU, GPU, RAM, disk, and the network. So for the design method, we're going to be using the agile method, focus on working code, small sections of new features added little by little. So we'll start with just disk monitoring. Once we have that down, we'll focus on the CPU, and RAM, GPU, and finally the network. As I said before, we'll be using the Oshi library to simplify collection. It's just the Java library that handles the actual collecting part. So with CPU, we'll start with static information, model number, base clock speed, the number of cores, as well as some more dynamic usage information, usage over 15 seconds, and the number of processes. For RAM, we can get the total amount of RAM available and the total amount in use. There's another mockup by Paul with the UI lookup. Disk, same idea as the RAM, the name, model number, capacity, amount used, and the read and write speed. And that can be broken down by each individual disk if the user has several installed, and it'll be displayed with several different tabs for that. And network will separate by the Wi-Fi and the Ethernet, with the inbound, outbound usage, Ethernet addresses for each device. Finally, the GPU only really be able to collect static data with the name, vendor, and the amount of VRAM available due to some limitations with Oshi. We can't get usage information through that. User requirements, we're going to collect data metrics for each device, pass them onto an SQLite database for storage, aggregate the data to a graph so it's easy to read and understand, and display it in a UI updated every 15 seconds. 15 seconds is just there to ensure, again, low overhead. It's not going to impact the system too much while they're using it, and they can get information as they're running whatever tasks they're running. Functional requirements, it's going to use Oshi to collect the metrics. It's Java library for collecting information about hardware devices over 15 seconds. Below, that's just some sample output of it running on my computer. It's not what the final product will look like at all.
All right, so for the general design of CRUM, we are building a Java desktop app utilizing Swing and Oshi for the Windows platform. The app will run locally on the user's machine, so there's no need to hook up to any sort of server or anything like that. And it will pretty much look and behave like the Windows Task Manager Performance tab, but with a few things taken out to maintain lightweight. So here, just as an idea, I mean, I had my prior mockups, but just as an example of what I'm talking about, this is the Windows Task Manager Performance tab, and CRUM will sort of be like this, albeit laid out differently, where each device, CPU, the memory, the different disks, the network, and the GPU, they'll each have their own tabs, and each tab will have the subsequent information that we'll be collecting as well as the graphs. And the basic flow of our software is the user will start up CRUM. CRUM will begin detecting what hardware components the machine has. Essentially, the problem with how we implement in the UI is most of the initial design has to be done statically. However, if I statically put 2 disk tabs and 2 GPU tabs to account for my machine, but we run it on a machine that only has 1 disk and 1 GPU, we're going to run into a problem. It's just not going to look right. So it'll detect for any multiples of the hardware components, and if it does, then it will dynamically create / add the tabs to the main UI. From there, it begins collecting the metrics from our different devices through the API calls. It'll send those metrics to our SQLite database. It'll aggregate it into a way that we can display it on a graph. It will then display said data. Every 15 seconds, it'll update the data. And after 1 minute, we'll delete the older records to prune and clean up the database. That way, we're not just like keeping really, really old information that's no longer useful. So for the UI, I'll be using GUI forms within IntelliJ. Now, what GUI forms are, if you've ever used the Eclipse IDE, it's the same as Window Builder, albeit with a couple changes, like there's no absolute layout, but that's more of a technical thing than anything important. It uses different swing utilities, your JFrames, your JPanels, your JButtons, all these different UI components. I'll be doing dynamic tab creation to account for the multiples of any hardware, which is detected at startup. And like I mentioned in the Windows Task Manager, each device with their subsequent metrics will have their own tabs, and that's where they'll be displayed.
Okay, so moving on to the database. Our database will use SQLite to ensure that the database is lightweight and doesn't take up too much space in the system. The database will still be stored locally on the user's computer. And here we have an ER diagram showing the tables and relations in the database. We have a table for the machine or the computer, which contains important information on the model and vendor that you get on startup. We also have a table for users so that there can be multiple users in using the system on one machine. And then we have separate tables for each type of system that we are collecting metrics from. And moving on to testing. So for testing, we'll be using JUnit and IntelliJ. Using this, it will be easier to catch most errors and it will be quicker to debug for fatal crashes. We are going to be developing unit tests to maximize our code coverage, and we also make sure to test on different hardware configurations. We're going to be making sure each of us run tests on our own machines, and since all of our setups of our computers are different, we should be able to get at least a small sample size of what it will look like on different types of Windows machines. Now, moving on to logging, we're going to be using SF4J to log the application details. And actually, we have to include this because SF4J is a dependency for using OC. During development, we're going to set up SFJ4, so we'll log pretty much everything that happens. But with the final release, we're going to be limiting the logging to only a few things that are critical, startup, edge cases, application crashes and errors, and for shutdown.
All right, so for our version control and issue tracking, we'll be using GitHub. We'll be monitoring the software's development through our commits. We'll be using issues to keep track of any bugs. We'll utilize branches and milestones to keep up with the agile development, focus on small steps of working code. And once everything's all completed and we successfully package the software, we will use GitHub to distribute the final package.
All right, so if there's any questions about CRUM or anything, you can message us on iLearn for our respective parts of the project.
Thank you for your time. We hope you enjoyed this presentation and hope you use CRUM in the future.